Good day, folks. Today we're going to take a look at Unit 2, Section 1. Now, in this section, we're going to look at how to graph a quadratic function using rules for transformation. All right, so go ahead and pause the video and write down your no's and do's. All right, let's jump straight into our first definition here. The first definition is for a quadratic function. What is a quadratic function? A quadratic function is a function that can be written in this form right here. F of x equals a times the quantity x minus h, that quantity squared, plus k. Now remember, the a cannot be equal to 0. In the past, you have graphed functions like this. These are linear functions. Notice it is x to the first power. Okay, that is what makes it a linear function, x to the first power. And if you graphed it, it would look something like what's shown right here, a line. Okay? Now, for a quadratic function, this is what I want to point out. A quadratic function has x to the second power. And if we were to create a chart for it, and then we were to graph the points, those points look like what is shown right here. And notice it's in the form of a U. Now, we have a special name for this type of quadratic function. We call it a parabola. Now, let's take a look at a parabola. A parabola, this here is called, well, I'll refer to it a couple different ways. I can call it parabolic form because it's a parabola, or your book refers to it as vertex form. Okay? So, the vertex form of a parabola, this h and this k, this is the vertex of the parabola. Now, that vertex point, depending on what your a value does right here, that vertex point will either be the highest or the lowest point on the graph, depending on how it is opened. Now, what I've done is I've graphed a few parabolas here for you. If you take a look at this, and I'm going to put my pointer right on this point, that's the vertex of this parabola. Now, is that vertex point a minimum or a maximum? Well, looking at it, it opens up. That is the smallest point on the graph, therefore it is called a minimum. Now, what about this one? Well, it is the highest point on a graph, so we call that vertex a maximum. Now, as we take a look at parabolas, there are different types of transformations, you're going to see two different types of transformations. The first one is called a rigid transformation, and of course the second one is a non-rigid transformation. We're going to take a look at a rigid transformation first. Okay, so here I have the standard form for a parabola, also known as what? If you said vertex form, you are correct. Now, this here is called the parent function, but you know what? When we get into college algebra, your college algebra textbook doesn't call it a parent function. It calls it a common function. So oftentimes I will use the word parent function or common function interchangeably. So just so you know, this is the parent function or the common function for the parabola. Notice the vertex point, hk. For the parent function, that hk is right there at 0, 0. Now we're going to look to see what happens to this if the h value, this point right there, is something other than h. For example, what happens if it is, for example, a minus h? Well, if it is a minus h, then it shifts to the right. In other words, that parabola is going to go here and it's going to shift to the right. Okay, now, what if it's a plus h? If it's a plus h, then it's going to shift to the left. Okay, go ahead and pause that and put that in your notes. Now, let's take a look at what happens if k were to change. If k is positive, plus k, it'll shift up. And if k is negative, well, like a minus k, then it shifts down. So here's an example where we take the function and I add k to it, whatever that k value is. And when that happens, that function moves up. Make sure you pause the video in order to get all these notes down on your Cornell note sheet. Okay, the next thing we're going to look at is reflections and non-rigid transformations. Let's start today with a reflection. Now, I want you to notice this value right there. It's an A value. That A value, if it is positive, it'll open up. But if that A value is negative, it opens down. Okay, so let me say that again. If this A value is positive, the parabola is going to open up. In other words, the parabola is going to be like this. However, if that A value is negative, then the parabola is going to open down. All right, go ahead and pause it if you need to in order to get that down. Now let's take a look at some non-rigid transformation. The bigger the A value becomes, the bigger this A value becomes, the more vertically stretched it becomes. And the closer that A value gets to 0, for example, between 0 and 1, the more vertically shrunk it becomes. Now, what does that mean? Well, let me show you an example here. If I were to have, say, f of x equals, say, 3x squared, that would take the parabola and it would vertically stretch it. In other words, it's going to stretch it vertically and it's going to be narrower. Okay, something similar to this. Now, if I were to give you something like, say, f of x equals 1/4 x squared. Well, notice that is an A value between 0 and 1. And that's going to vertically shrink it. In other words, it is going to become less steep or wider. So that parabola will become vertically shrunk. It's going to become wider. In this slide, I want to point out some advanced reflections that we're going to study later. For example, what happens if I change the x negative? What does it do to it? Or if I change the whole function negative, what happens to it? Well, guys, just remember that there's more to the reflections than what we've talked about. And we're going to talk about these another day. Okay, well, let's start with a few examples here. So the first thing I want to do is it says, well, let's read the question first of all. It says, the parent function is moved left 3 units and up 5 units and is 1/2 as steep. Write the new function. Okay, so let's take a look at that. First thing, when you do something like this, the first thing I want you to do is I want you to draw a picture of the common function, which is also called the parent function. Alright, so there's my common function. And that function, remember, is just f of x equals x to the second power. Now, what we're going to do is, let's just remember, let me write this down. If I say f of x is equal to a times the quantity, x minus the h, quantity squared, plus k. Now, remember, the h moves it left or right, the k moves it up or down, and the a value is what makes it wider or narrower. Okay, so let's identify which of these pieces goes where. Alright, so first of all, I see left 3 units. Because it moves left 3 units, remember what you wrote down in your notes, left means plus h. Okay, so what I'm going to do is I'm going to plug a plus 3 right there. Then I see it moves up 5. So I'm going to plug a 5 right there. And then I see that it's 1/2 as steep. So that means I am going to plug a 1/2 right there. So what is this going to look like? Well, here's what it's going to look like. It's going to look like f of x is equal to 1/2 times x minus an h, the quantity squared, let me erase that because I didn't mean to put that h there. I meant to put a plus 3 plus the 5. And that is what the equation will look like. Now, what will that look like on the graph? Well, let's go ahead and put it on there. I see it's going to move 3 to the left. It's going to move 5 up. 1, 2, 3, 4, 5. So the vertex point is going to be right there at negative 3, comma 5. And then it's going to be wider. It's going to be half as steep. So that function, and we're just going to kind of sketch it in there. And that is what the parabola will look like. Okay, let's take a look at another one. It says the parent function is reflected across the x-axis. Reflected across the x-axis means your a value is going to be what? Positive or negative? Okay, it's going to be negative. Okay, it also says it's 5 times as steep. In other words, it is really going to be steep. And it is translated down 4 units. Okay, so let's go ahead and write this new rule. Alright, so to begin with here, let's draw our common function. We always start with the common function. Okay, so that kind of sketches the common function. Remember, that is going to be f of x equals x to the second power. Alright, so first of all, it's 5 times as steep. What is that? Is that an A or an H or a K? If you said A, you are right. Okay, so that's going to be our A value. Translated down 4. Okay, down 4. What does that mean? Is that H or K? Well, look back at your notes. What is it? If you said K, I agree. And then there is no horizontal translation. So since there isn't no horizontal translation, that means the H value is just going to be a 0. Or we don't even have to put it there at all. So let's go ahead and do this. So it's going to be f of x is equal to, you have your A value, then it's going to be x minus your H value, the quantity squared, and then plus your K value. So let's put those in there. Alright, so it says 5 times as steep. So it's going to go like this. Okay, then I see it's translated down 4 units. That means it's going to be a negative 4 right there. And then I see there is no horizontal translation, so that's going to be 0 right there. Now, let's look at it. It says one thing more. It says it's reflected across the x-axis. That means that this 5 is, because see, if it's reflected across the x-axis, that means it opens down. And if it opens down, that means that 5 is a negative. Now, let's clean this up a bit. So if we clean this up again, I see f of x is going to be equal to negative 5 x to the second, and then a plus and a minus make a minus, so it's minus 4. And that's what it will look like as far as the standard form for a parabola in vertex form. Now, let's go ahead and look at what that will look like graphing-wise. Well, if we graph it, let's just follow the directions up above. It's translated down 4 units. Okay, so we go down 4 units. And I'm going to put a dot right there because that's where the vertex point is. It's going to be at 0, negative 4. Then it says what? Well, it says it's going to be fairly steep, and it's reflected across the x-axis, which means it opens down. So my parabola is going to be something like that. So it's shrunk in, it's steeper, okay? It's more narrow, and there we go. Okay, we're going to look at one more of these. Okay, it says the parent function is reflected across the x-axis 3 times as steep and moves right 5 units. Write the new one. Okay, so let's go ahead. First of all, we're going to draw a graph. Here's my parent function, or common function, and that is going to be f of x equals what? Did you say x squared? I think I might have heard you say that maybe. Okay, so anyway, let's take a look at that and what's going to happen. Well, first of all, let's just draw this in. It's f of x is equal to, there's the a value, times the quantity, x minus the h value, the quantity squared, plus your k value. Now, let's see what we know. First of all, it says reflected across the x-axis. So that means that a value is going to be negative. Okay? It's 3 times as steep, which means it's going to be narrower. So we're going to put the 3 right there. It moves right 5 units. Okay, now remember, go back and look at your notes, and what does it say? If it moves right, it's going to be a minus h. Okay, so that means it's going to be a minus 5 there. And how does it move horizontally? Well, I don't see a horizontal movement. So we could, if we wanted to, just put a 0 there. Or nothing there at all. So let's clean this up a little bit. So when I write this out, it's going to be f of x is going to be equal to negative 3 times x minus a 5, the quantity squared, and I can just stop right there. And there's my equation. Now, let's go ahead and do the transformation on the graph. When I do the transformation on the graph, let's see here. Let's just use the directions up above. Okay, so first of all, it moves 5 to the right. So 1, 2, 3, 4, and 5. I see it opens down because it's reflected across the x-axis, and it's 3 times as steep. So it's going to look something like this. And again, when I draw the steepness of it, I'm just kind of sketching it. I'm just approximating it. So, and that vertex right there is going to be at 5, 0. That's the vertex point. And let's see. That looks like that's my graph. All right, guys. Well, let's pause it right there. Make sure you get these notes down really well. All right, folks, we have 3 more examples. But you know, here's what I want you to do. I want you to use your notes that you've taken so far, and I want you to sketch the graph of these next 3 and have these all ready for when you come into class next time. So we're going to take the first few minutes of class, next class period, and I want you to show us what you have for examples 4 and 5. Here it is, so pause it, go ahead and graph it in your notes, and for 6 as well. All right, so go ahead and pause it and graph this one as well in your Cornell note sheet. And then what we're going to do is when you come to class, we're going to do a little activity. Matter of fact, we're going to have a snowball fight. Okay? And in dealing with that snowball fight, we're going to practice some more of identifying different graphs along with their function form. All right, guys, and then following that, of course, we are going to do a worksheet in class to further practice after we play in the snow, metaphorically speaking. Okay, guys, well, that's a wrap, and I will see you in class.